Good everyone, welcome back to our second class of what machine. So today we'll be treating the second class of our machine. In the first class we talked about what the classifications of machine and how machine was evolved and the general principle of operation of machine. So in today's class we'll be discussing AC machine, and also our previous class was strictly after talking about giving a brief knowledge about machine. We decided to talk about DC machine. So in this class, supposed to be brief because in today's class we'll be dealing with what AC machine. Now, what is an AC machine? If you want to know the definition we give or the explanation we give for what DC machine, then you can check our previous video because it's part 2 of what machine. Now, an AC machine, normally we know an AC to be what alternating current, right? And we already know machine to be what a two-way thing, a machine that either convert electrical energy into mechanical energy or mechanical energy into electrical energy. So for an AC machine, we say an AC machine are electrical machines that either they convert AC electrical energy into mechanical energy, or they convert mechanical energy into AC electrical energy. So it means it's either for AC machine, it's either you have AC motor and you have what a generator, right? So it's either AC machine is converting rotational energy into AC electrical energy, or AC electrical energy into what mechanical energy or rotational energy. Now, in most cases, AC machines have the following basic part, or let me say, two main basic part. As we all know for machines, the armature winding is located on the stator, and we know the stator is the stationary part of what the machine. Normally, you have two types of winding in a machine. We have what the armature winding, and you have what the feed winding. For the armature winding for AC machine, the armature winding is located at the stationary part, which is also known as what as at the stator, right? While for the feed winding is located at what the rotor. And don't forget, the rotor is what the rotating part of what a machine, or you can call it that shaft that normally rotates in what in a machine is also known as what the rotor. That rotor is gotten from what rotation. So it's the what rotating part of a machine. So the feed winding is located at the rotor, while the armature winding is located at what the stator. This is one key difference between what an AC machine and what a DC machine. Now, this arrangement makes AC machine easier to insulate and maintain. And since the high voltage winding is on the stationary, because the high voltage winding of what an AC machine is located at what at the stator, right? It's located at the stator. Because of this, it's making what the insulation easier, and also for what for maintenance. Now, we have types of AC machine. Uh, Based on this class, we are going to divide AC machines into three into three what category, or three classes, where we have what our AC machine, or our AC motor, we have our AC generators, and we have transformers. But you may be surprised that in our class we said what an AC machine, or a machine, has what two main parts, the stator and the rotor, or the stationary part and the rotating part. What about a transformer? Does transformer actually have these two main parts? You know, normally most of the main part you see in a transformer is what the stationary part. However, a transformer has what a moving, or a moving magnetic flux. The magnetic flux in a transformer, after it has been excited, is not stationary, it's moving. So it's not static, right? It's not static, it's moving. So because of that, we tend to classify a transformer into what AC machine. And also, when you check through other textbook, we have many textbook, and they give different explanation why transformer was included as what a type of what AC machine. And I doubt if there's any textbook that you will see on this earth that when it's talking about classification of what machine it will not mention transformer. So definitely the three types of AC machine we have are we have motor, we have generator, and we have what transformer. Now normally you can see say okay, why will transformer be what a machine when a machine is mainly to convert electrical energy into mechanical energy or mechanical energy into electrical energy. Then which what is transformer doing? Normally the main function of transformer is for transformation of voltage or transformation of what electrical what signal, if you call it that. It transform an AC signal into another form of what still AC signal, even when it's not changing the AC signal, but its main function is what to transform what the voltages. Now for AC motor, we say for an AC motor is what a device or a machine that convert what AC electrical energy into mechanical energy. While AC generators, they are also known as what alternators. They convert mechanical energy into what electrical energy. Now you have to keep this behind your mind. Now AC machines are energy conversion using alternative what current. It means for AC machine, what its main source is what AC, right? Now for stator usually carries what the armature winding, while for rotor usually carry what the field winding. This make what the basic difference between what an AC machine and what a DC machine. Now, what is an AC motor? An AC motor is what an electrical machine that convert AC current, or let's say AC electrical energy, into rotational what mechanical energy. In simple terms, it uses AC power to produce motion. That is what it means. Is using what AC power. You connect it to what to an AC source, then it produce what motion. That is simple definition, simple explanation for what an AC motor. Now we have types of what AC motors. In the AC motors, we have what an AC motor is either what an induction motor or what a synchronous motor. Right, as you can see here, we have an induction motor or what a synchronous motor. Now, for an induction motor, is also known as what asynchronous motor. Now, it's called asynchronous motor because it has a slip, right? It means the rotor speed and the magnetic field speed are not the same because of what is the slip. The rotor speed is usually lower than what the magnetic field speed. So because of that, we call it what asynchronous motor. It means they are not in synchronism. The rotor speed and what the magnetic field speed. And also we have what our synchronous motor. A synchronous motor operate at what constant speed, or you call it what a synchronous speed. It means the rotor rotates in synchronism with the stator magnetic field. So it means the magnetic field of the system or of the machine is in synchronism with the rotor speed. So because of that, we call this type of motor synchronous motor. However, those kind of motor are not that common because the types of motor that are very common in the society are what induction motor. And also keep this down. AC motor convert AC into what AC signal or AC electrical energy into what mechanical energy. Now we have the two main types. You said we have what induction motor. They are very common, but does not have what a constant speed or synchronous speed. While for the synchronous motor, they have synchronous speed, but they are not that what common. Now let's talk about induction motor. An induction motor is a type of AC motor that convert electrical energy into mechanical what energy based on the principle of what electromagnetic induction. Now this is one of the second key difference between an induction motor and a synchronous motor. Now an induction motor is using the principle of what electromagnetic induction. Now, what is electromagnetic induction? In one of our classes, we discussed electromagnetic induction as the process. Let me try to explain it what in a layman term. Now, you have two coils, right? You have two coils. Let's assume you have coil A and coil B. Coil A was connected or is connected to a source, right? Which means as current is passing through the coils of coil A, it will tend to produce magnetic flux according to Faraday, right? It will tend to produce magnetic flux. And now you have another coil that is not connected to that to that coil A. Let me call it what coil B. If there now what that coil will do is that the magnetic flux that was generated from A, then that coil B will tend to cut the magnetic flux then, and what an EMF will be induced in that other coil. This is the simplest way, or this is the simplest way I think electromagnetic what induction can be explained. That you have two different coils. One is the one producing the excitation, while the other one is cutting or cutting the magnetic flux that was generated by the first one. Then an EMF what is induced in the first what in the second coil. Now, because the rotor always runs slightly slower than synchronous speed, because it's because of this we are calling it what? Asynchronous motor. Then the induction motor is also called asynchronous. Okay, that's what that types of what induction motor. Now, based on the type of power supply, induction motor are classified into two broad categories, which are the single phase induction motor and what the three phase induction motor. Normally, the single phase induction motor, they are very common because you use them for what? For because it's mainly used for light load. You see them in fans, ceiling fans and other fans. You see them in air conditioners. You see them in washing machine. However, for the three phase, it's mainly for what? Industrial use, for big machines and what equipment that are mainly used in the industry. Now, the key characteristics of what induction motor, or the key features of what induction motor. One, they operate below synchronous speed. That is one. This is telling us that the rotor speed is always slightly less than the synchronous speed because it has what? Slip. Then two, they are self-starting. Yes, they are self-starting. This kind of machines, they don't need an external starter. They use what? They don't need an external starter or an external exciter. They use what? Mutual induction, or you still call it what? Electromagnetic induction. They use what? Mutual induction principle to get what they are for the induction. So it means you just excite or you connect the main coil to the source, while the other coil get cut across the fluxes that is generated by the first coil using what? Mutual induction. And also they are simple to construct and rugged. So this make it what? Highly reliable and easy for maintenance. Also, quick note for students. Induction motor, they are mostly used AC motor. They works on electromagnetic induction and they have what? Slip. Because of they have slip, then it means the speed is less than the rotor speed is less than what? The synchronous speed. Now let's discuss what? Synchronous motor. Now, what is synchronous motor? So, synchronous motor is a type of AC motor that operates at a constant speed known as the synchronous speed, right? It means in this motor, the speed is exactly equal to the speed of the rotating magnetic field, which means the magnetic field, the speed of the magnetic field is the same with what the rotor speed, right? The speed of the magnetic field is the same. I'll add the same value with the rotating speed, because this kind of motor does not have slip. Yes, because it does not have slip, then it means what? The magnetic field speed equals what? To the rotor speed. And your magnetic field speed depends on the supply frequency. Yes. So a synchronous motor has two magnetic field. One, the stator magnetic field, which is produced by what? The AC you connect it to, which is what produced by what? The AC supply. Then you have rotor magnetic field, which is produced by what? DC excitation or permanent magnet. Now it means for your rotor, you need a separate or a different excitation or different exciter to excite what? The rotor coil, right? Unlike what? The induction motor that is using what? Mutual induction process or electromagnetic induction process. But for synchronous motor, you have to excite the two coils separately. So you connect the armature winding to your AC supply, while the rotor you said that you use what, a battery source. Let's say this is excitation, or you are using what, a permanent magnet. Now, because both fields are present, it is called what, a doubling excited machine. So it means a synchronous motor is also called what, a doubling excited machine, because it's at the field winding and the rotor winding. Yes, at both windings, right, at both feet, either the armature winding and the main field winding, they both need what, excitation. Now, applications of what, synchronous motor. Small synchronous motor are mainly used in electric clocks, timers, in what, appliances. While for the large synchronous motor, they are used in mainly for what, industrial what, application, such as power factor what, improvement and driving heavy machines. Now, the key features or the key characteristic of what, synchronous motor are: one, they have constant what, speed operation, which means they are synchronous. The magnetic field speed and the rotor speed are the same. And two, not self-starting, dey requires what, an external method to start them. And three, requires rotor excitation. And four, power factor control. It can operate at leading, lagging, or unity power factor, making it useful for improving power system factor. Now, AC generator. AC generator is also known as what, an alternator, right? Because we have been discussing about motor since. An AC generator is also known as what, an alternator. And in simple terms, normally most alternators we see, what they mainly do is that they, like the alternators we have in uh, the alternators we have in vehicles, right? Their main function is that they convert signal into what, a rectified what, signal, right? Mainly they use them for starting cars. Now let's define what, give a proper definition for what an alternator. An AC generator, also known as alternator or synchronous generator, is an electrical machine that converts mechanical energy into alternative current electrical energy. Now it means this is what an AC generator, it simply convert rotational energy or mechanical energy into what, AC electrical energy. So in simple terms, it is the direct opposite of what an AC motor, right? It's converting mechanical into what, AC electrical energy, while our motor do the opposite. Now, types of what, AC generators. AC generators are classified into two types, just like what, AC motors. We have single phase AC generator and we have what, three phase AC generators. Now, for the single phase AC generator, produce they are commonly used in homes, small offices, light, for commercial application. Most of those single phase generator, like in Nigeria, we have a particular type of generator that they normally call what, better pass my neighbor. Majority of them, they are what, single phase that most people tend to use in what, their various homes and what, offices. And also we have a three-phase AC generator. This is mainly used in what, industries and what, power stations, then large scale power generation. Now the key idea that you are supposed to keep behind your mind for what AC generator is that it convert mechanical energy into electrical energy in AC form, also called an alternator. Then three-phase generators are more efficient and commonly used in power system. So actually we are going to end our class here because we wanted the class to be very short. So we did only just 10 slides. So with this, normally we are supposed to cover a lot for this AC generator, but because of time, we just wanted to restrict it to this particular one. And don't forget, try to get other textbook to have more understanding about the topic. And also, if you have any question, feel free to drop it at the comment section, and I will try my best to answer whatever question that was dropped. And don't forget, please try to like, share this video to others that may need it. So for now, bye and have a nice day. Don't forget, Spark Scholar, from idea to paper. Bye.